Good evening, everyone. Thanks for coming out to join us here at the Tompkins County Public Library. It's fun after having been traveling around the county and doing these presentations in each town to end here in downtown Ithaca at an institution that we all know and love. As Brian said, my name is Matt Johnston, and I'll be presenting the HeatSmart program to you this evening. I'd like to first acknowledge our partners and collaborators in the HeatSmart program, first and foremost the Park Foundation, along with the Tompkins County Planning Department, Cornell Cooperative Extension, and the SUNY Department of Physics, SUNY Cortland, that is, and particularly the program on sustainable energy systems. They've all been a great help in having us put this program together and administer it to residents of the county. And just a word on the Solar Tompkins board. The board members, we have Brian Eden here tonight, as well as Mark Whitmer, who's behind you, spend a lot of time, volunteer above and beyond what they spend their daytime work hours doing to help organize and deliver these programs to county residents. So we're thrilled for their participation in this program as well. So tonight I'm going to be presenting Cost, Comfort, and Climate, Harnessing the Efficiency of Heat Pumps and Improving Home Energy Performance in Tompkins County. In essence, a long title, but that is what the HeatSmart program is about. So Solar Tompkins is a nonprofit community-based organization. We promote the rapid adoption of renewable energy throughout the county. Many folks are probably aware of the past solar campaigns that Solar Tompkins has administered. Solarized Southeast, and then the Switch to Solar campaign last year, which were each very successful and nearly tripled the amount of solar at work here in Tompkins County. So what is HeatSmart? This year we thought we'd change the focus a bit. So the solar market has really been ramped up and has sustained itself well in Tompkins County. And a number of folks have come back to us with feedback saying, that's great, we're harnessing renewable energy, we're bringing that into the home, but shouldn't our homes be as energy efficient as possible from the inside out, so that when harnessing solar, we really have a highly energy efficient, well-performing home? And Solar Tompkins mulled that idea over and said, absolutely. How do we start from the inside out? And that's why this year we're focusing on building energy efficiency through insulation and air sealing, as well as highly efficient air source and ground source geothermal heat pump systems. We've really broadened the program from just solar to insulation and air sealing and these varieties of heat pump systems, which I'll speak with you about tonight. Our goals this year through the program are to facilitate more than 100 homes in Tompkins County adopting any degree of these home energy performance measures. It could be just insulation and air sealing, it could be just the heat pump system, or a package of each together. Our goals are both local and global in terms of aspiration. We really are aiming to reduce fossil fuel use here in Tompkins County, as well as mitigate regional and global climate change. We will sustain local and regional jobs. One great success of the solar programs was that by working with local companies to ramp up these markets, each of them experienced a tick in job growth internally, and that's great for our local businesses, and we hope that these installers that we're working with this year, which you'll have a chance to meet with and speak with at length later on this evening, will experience the same for their companies, as well as the other companies we know are doing similar business here in and around Tompkins County. HeatSmart Tompkins is predicated on a very successful programmatic delivery model. It's called the Solarized model. It's a U.S. Department of Energy structure that was used for the solar programs that, as I said, we've expanded for HeatSmart in terms of our products and services offerings. We're seeking to eliminate the barriers to heat pump and energy efficiency adoption. When we decided to take on this program, we really said, we believe that there's a lack of familiarity with heat pumps out there in the marketplace. Now, when you drive around Tompkins County and you see solar everywhere, you know that something's happening here and it's been successful, right? You see it any part of the county, whether it's on roofs, or out in fields, or if you've read a little bit about the new community solar initiatives being offered, it has arrived in Tompkins County. When was the last time someone said, hey, why don't you come into my basement? Why don't you come around the back of my house and check out my heat pump, right? Probably not all that frequently has that happened. And that's a conversation we'd really like to initiate here. So part of our public education campaign is to, help people get more familiar with what heat pump technology is, and even the topic of insulation and air sealing. You know, at some point it just falls on deaf ears. People say, oh, it's something I should probably do, or I think my home is well insulated, and really we don't know what's happening behind our walls, or in our attics, or in our basements. So we put these all together to deliver HeatSmart. We believe we've created a simple process with vetted technologies and well-vetted installer partners. As far as we know, this program, unlike the solar program, is the first of its kind nationally by taking on insulation and air sealing and heat pump systems together and delivering them sort of as a suite of services offered at below market rate pricing to residents of a locality. So being the first of its kind, we thought, hey, we can't just take this to the market without developing some best practices and some real robust standards with which to build this off of. So we did some studying of other states that are doing similar programs and put together what we feel are a very healthy set of best practice standards that both keep us as an organization accountable to a high level of programming that we bring to the community, as well as our installers bringing the best practices in the marketplace today for the installation of insulation and heat pump systems. And we're now at the end of our educational outreach campaign. And then after this, we hope that enrollment will be a choice of yours that you will take us up on. And once enrolled, we have a deadline of January 31st, 2016 to choose to go to contract with one of the installers in the room today. So during our Q&A at the end of this presentation, we'll talk a little bit about the no obligation enrollment process, and then I'll remind you of that contract deadline of January 31st, 2016. Because the benefits of joining the HeatSmart program are receiving below market rate pricing for participants who go through to contract, and also being well versed in the financing options available both with our local institutions here in Tompkins County, as well as those institutions that the installers bring to the program themselves. And we also like to keep in mind that just like the solar programs, this is a limited time offer. These are one-year programs, and that's why we do the education campaign up front. And we hope that folks will take advantage of this limited time offer to go through a local program and adopt what we feel are environmental, economic, and socially good practices when it comes to home heating and cooling. So why is the HeatSmart program needed? 75% of our home energy use in Tompkins County goes towards heating, cooling, and hot water use. Of this energy use total, 70% is from fossil fuels, and so being squarely in line with some of the other efforts here in Tompkins County, namely the greenhouse gas reduction goals of the Tompkins County Comprehensive Plan, as well as Cornell Cooperative Extension's residential energy efficiency programs and the town of Ithaca's new resident energy benchmarking program that benchmarks energy use in the residential homes in the town of Ithaca. We feel that this program puts us well in line with a lot of the other efforts locally to consider energy, consider the environment, and sort of our identity and character as a community, both at home and beyond our property lines. Thanks to NYSERDA here, this point is last but not least, the upstate climate zone is generally the most cost-effective market for heat pumps due to lower equipment and labor costs. And believe it or not, we experience some of the lowest winter electric costs in comparison to some of our northeast neighboring states, namely the New England states. And why do we feel that HeatSmart will work? There's a number of compelling economics for making improvements on an energy level in the home, the reductions in equipment costs that I mentioned just a moment ago, as well as a dearth of incentives and tax credits that are in the marketplace today, more so than ever before, as well as accessible financing. There's a real desire to be able to heat and cool one's home cleanly and comfortably. And again, going back to the results of the solar program, that's one thing that we learned. People said, it's great, we're thrilled to go solar. It makes economic sense for me, it makes environmental sense. But if the home isn't tight, as they say, or well sealed from the inside out, am I really harnessing solar to the best of its ability or to the best of my dollars spent on my utility bill? And the answer is no. So that's why we're broadening the program with heating and cooling systems from the inside out. And we know that these will increase the marketability of one's home as well as property value overall, creating an environmental legacy for that property. And as I said just a moment ago, our residents here have come back to us to say that we believe environmental benefits extend beyond property lines to strengthen our community at large. So we appreciate it if you focus on these technologies for your program in 2015 and 2016. So what makes for an energy efficient home? I'm going to speak a little bit about the insulation and air sealing portion of the program and the technologies behind it before going into heat pump systems specifically. And when it comes to insulating and air sealing one's home, it's true that no single measure alone can achieve energy efficiency in your home. It's a complicated analysis to see how energy is being used in everyone's home, and depending upon architectural vintage, occupancy behaviors, which are very important actually to determining energy use in residential homes, as well as the state of one's insulation or lack thereof, the state of windows, etc., really require a comprehensive approach to the building envelope. That's the imaginary line around the conditioned space in one's home, the conditioned space being the rooms that we use most regularly, our kitchens, bedrooms, bathrooms, etc. Not so much the attic, not so much the basement, although some of us have finished basements. But that's really the focus here, is to make that conditioned space function as best as it can from an energy perspective. There are a common mix of improvements that can make a significant difference in most homes, and each of our installer partners are well practiced in how to come in and identify immediately where in your home you can improve insulation and air sealing to tighten it up before even considering adjustments, improvements, or a whole new system for heating and cooling. People often consider insulation sort of the low-hanging fruit of residential energy efficiency, and I agree with that statement in general, but these improvements can really add up in cost, add up in the different areas of the home where it's applied, right? So there can be a lot of fruit on the tree, and even if it's low-hanging, that can add up with regard to costs. So it's something I'd just like to point out as I go through the topic here. So a majority of homes in the US lack insulation in key places. I mentioned the building envelope. I know the graphic in the top right here is a little bit small, but if you can see the red line around the conditioned space of this graphic, again, that is the building envelope, and insulation and air sealing looks to improve heat and cooling retention in those spaces. These red arrows here, up through the attic, are common places where thermal heat loss occurs, often through vents for ductwork or the fixtures around can lights or fans in bathrooms. Thermal heat loss commonly moves out from those places. And then air leaks commonly occur, whether it be through windows or in the basement, through the foundation itself, through the exit piping for dryers, etc. So what's the common state of our housing here in Tompkins County? If anyone has an unfinished attic, like this graphic in the top right, or an unfinished basement here, you're obviously a prime candidate for HeatSmart. But a quarter of the homes in upstate New York are 75 years or older. Almost half of them have no foundation insulation, and almost 7% have no wall insulation. That's pretty significant given the fact that we live in a cold climate and have done so, if we've been residents for a long time, that these stats remain as striking as they are. One thing I'd like to point out in this slide is that we've separated these stats from the downstate market, from New York City, let's say. We're focusing primarily on single-family homes in the upstate market, not accounting for multifamily buildings, apartment buildings, population density downstate. So I like to point that out for a lot of the statistics that I present in this presentation. And so when it comes to insulation, we offer a variety. We, HeatSmart, and really the installers, offer a variety of insulation types through the program. The first being cellulose, which is commonly applied loosely in attics or dense packed in walls or sealed cavities. It's typically a natural material. It has a moderate R value, and I'll explain R value specifically on a slide ahead. So cellulose is one of the common products that when an installer will come to your home to do an energy analysis, they will typically suggest as a type of insulation to consider for an attic, let's say. Closed cell spray foam is another variety of insulation that our installers offer in this program. It's a synthetic plastic material that is blown in liquid form and then hardens sometimes as quickly as in 30 seconds. If not, on a larger job, may take a little bit longer. Provides both an air sealing and vapor barrier to the spaces that it's applied to, or to the surfaces that it's applied to. Typically in the past, the blower agents in these spray foams have been HFC-based, hydrofluorocarbon-based, which have typically had a high concentration of greenhouse gases. Those, as well as water-based spray foam blower agents, are still out there on the market, although we've arrived now at 4th generation spray foams, which can have very low GHG emissions or a very high R value that is in combination with low greenhouse gas emissions. And if that's something that you're interested in as a potential enrollee and customer in this program, you can inquire with your installer partner about. Spray foam is commonly applied around the rim joists of homes you see in the image at left, or in a basement space in this image at right. If you really only have a crawl space, access usually isn't an issue. Someone's on staff to get down into those spaces for you. I mentioned R value 2 slides back, and R value is a measure of the resistance of a material to heat flow. The larger the R value, the slower the heat moves across the boundary of that material. So the higher the R value, the more effective that insulation product is. And these are some of the common targets here for these areas of the homes that the installers are aiming to achieve when it comes to installing insulation in these different parts of the home. On the attic flat, an R value of 49. As we know, heat rises, so you want a high R value there so that heat does not move easily across the boundary of that cellulose insulation in the attic. On a basement or crawl space, in the rim joists, may shoot for an R value of 18. Basements, same number. And walls, you can insulate those a number of ways, whether it's a hard spray foam or with cellulose, and that can range from 20 to 25 with regard to its R value target. Fiberglass, it's a common product, right? It's still on the market. You can go down to Home Depot and see it offered there. We're not offering it through HeatSmart. It's been shown to have a relatively poor R value overall. It can emit styrene, which is a possible carcinogen, and it's been shown to reduce lung function both in people and in our pets. So we've decided to just leave it out of the HeatSmart program, and the 2 products, cellulose and spray foam that I highlighted earlier, really are the best bang for your buck products out there, and that's what the installers in this program will be offering to you. On this topic of health and safety when it comes to insulation and air sealing, our best practices take into account the health and safety aspects of the application of spray foam. So with regard to building airflow requirements, for any insulation job, natural or mechanical ventilation as needed will be something that our installers will communicate to you depending upon the size of the insulation job. It may be required that residents spend anything from any time of anywhere from a few hours to 1 overnight out of the home while the air quality returns to normal. And then with regard to the proper handling of any hazardous existing insulation, vermiculite is a substance that can still be found in some older homes here in Tompkins County. It contains asbestos contamination. It's commonly found in stovepipe insulation or on in-insulation tape around ductwork. And each of our installer partners are trained to visually recognize vermiculite when they come to the home to do an energy assessment. One note on this is that if there is vermiculite that is found to be in the home, it can put a temporary stop to the installation of new insulation because it requires a certified contractor to come into the home and remove the vermiculite contamination first before going ahead with a new type of insulation. So what then is the value of a well-insulated and air-sealed home? First and foremost, it saves energy and money on your utility bills. In addition to that, it can improve humidity control. Some other improvements that are common to the home are listed here on the slide. Ice damming being first and foremost. With the intense winter that we had last year, it wasn't uncommon to drive around the county and see a number of homes with some pretty serious ice damming. And a lot of people think, well, the sun came up that day and it melted some of the ice on the roof and then it just ran down to the gutter and it froze again. It's really not a big deal, right? It's just weather. But really that's a sign of inadequate insulation in one's attic, that ice damming that occurs. And we know that that can then lead to leaking in one's roof, and water damage isn't fun to experience in your home. And it can also damage the gutter system by building up there and adding a lot of weight to the edge of the home. So another benefit of new insulation in one's attic is reducing the harm of ice damming. And then of course, better insulation can reduce noise from the outside and prevent pest intrusion. Once your home is well insulated and air sealed, you can move on to consider improvements to your home heating and cooling system. Almost 20% of natural gas systems and almost 30% of fuel oil heating systems are more than 20 years old in the average upstate single-family residence. More than 80% of central AC systems statewide are not high efficiency, and that makes heat pumps particularly attractive to homes using propane or fuel oil here in Tompkins County, as we know that those are the most expensive types of heating and also combust in the least efficient types of heating systems. When it comes to the sizing of heating systems in our homes, they're sized on a design day basis, which represents the temperature temperature above which 99% of the hours of the year are in our climate zone. It's a mouthful of a sentence, if you want to read that one again. Temperature above which 99% of the hours of the year are in our climate zone. So for heat pump systems through this program, we use a design day temperature of 0. And heat pump system sizes are presented in the unit of tons. 1 ton is equal to 12,000 British thermal units per hour. A BTU, British thermal unit, is an arcane measure for the amount of energy it takes to melt 1 ton of ice over a 24-hour period. And that's still the metric we're using for sizing our home heating and cooling systems today. So what then is a heat pump? They are a common electric powered technology used in our refrigerators or our in-window AC units. We've all had refrigerators for decades now, and really, the heat pump functions like a scaled up version of your refrigerator. In reverse, really, if you're heating, but if you're cooling in the summer months, it essentially is very similar to the process of the refrigerator, and I'll go into details here in just a moment. But they supply warmth in the winter and cooling in the summertime. They're effective at low temperatures common in our region, and there are 2 basic types. Air source heat pumps move heat from the outside air in wintertime, and ground source geothermal heat pump systems move heat from underground into the home in wintertime. Both varieties of systems can switch operation to provide cooling in the summer months as well. So it's heating and cooling. I tend to talk about heating in this presentation because we have a lot more heating days here in our climate zone than we do cooling days, but do keep in mind that all heat pump systems are both heating and cooling. They say there's no such thing as a free lunch, right? Well, people often also ask at times, heat pumps seem to be magic, how does it really work? And this is the free lunch. If installed and operated and commissioned appropriately through contractors like the ones who we're working with HeatSmart this year that are all BPI certified, that's Building Performance Institute, which is a national accreditation, then both air source heat pumps and ground source geothermal heat pump systems can operate at above 100% efficiency. It's not uncommon for systems that are, again, installed correctly, I should say sized first, then installed and commissioned correctly to operate at 200%, if not more, percent efficiency, and ground source systems at 300% or more efficiency. In comparison, fossil fuel heaters tend to range from 70 to 95% efficiency, and this is because they are combusting fossil fuels, right? They are generating heat from fossil fuels. Heat pumps do not generate heat. They extract heat from the air, just like our refrigerators do, and then through the refrigeration cycle, change the temperature of that heat and provide heating or cooling. Because they're not combusting fossil fuels, they don't lose the efficiency that brings down the operability of that system below 100%. And with gains in technology in this market over the past couple years, their electric-based efficiency has grown so high that they're able to function above 100%. So for ground source geothermal systems, 1 unit of electricity is used to provide 3 units of heat energy to the home. This is achieved by the pump system and the compressor extracting renewable heat from the ground, cycling it into the home, and then taking that heat or cooling back out of the home in the next season. What are some of the benefits of a heat pump system? A lower operating cost than our traditional furnaces and boilers, fossil fuel based, no on-site combustion, longer life expectancy for these systems, low maintenance overall. They can absolutely meet 100% of home heating needs, even here in our climate zone, and they have a much lower environmental impact by reducing greenhouse gas emissions by not combusting fossil fuels. I'm going to talk now specifically about air source heat pumps. See this unit here on the wall? This is a head or a mini split unit. And as I said, there are 2 types of systems. There are ducted air source heat pump systems that tie into the existing ductwork of one's home. And there are ductless air source heat pump systems, which are these individual interior wall-mounted units connected also to a compressor located outside the home. What's nice about air source heat pumps is that with these 2 types, it offers the variety to heat the whole home using existing ductwork that you may have, or to heat select rooms by having 1 outdoor compressor and several heads, or these mini split systems, typically wall-mounted, around the home to provide a zone-based heating and cooling method. Installers come in, they decide what sizes of the units in the ductless example, where they should be placed so that heating joins together and it's comfortable and consistent throughout the home. But for example, if anyone says works from home or spends a lot of time at home by day, say you're downstairs in the living room or a kitchen, you may program one of these to be at a comfortable temperature, let's say 65 maybe, downstairs. And we know that heat rises anyway, and maybe you're not upstairs in the bedroom if you're in a 2-floor home. So maybe you set the upstairs units lower and you don't have them adjust until the nighttime when you tend to use the bedroom. What's nice about the ductless systems is that you can individually program the heads or the split units to heat and cool by area of the home. This is how an air source heat pump system works. This depicts a ductless air source heat pump system. So you have the compressor here that you see on the graphic. It's located outside. In our best practice standards, we like to have our installers locate these either about 20 inches off the ground or even bracket them to the side of the home. They function best when air can move cleanly across them. That's what they need to extract heat from moving air. They oftentimes look very much like the main units for central AC. They're actually smaller. They're about 2 by 3 when located outside. And this is just a graphic representation, but these refrigerant lines adhere to the house. They run very much like an electrical conduit up the wall through an incision point, and then those lines will run in the wall cavity to meet one of the head units on the wall and connect to the back of it. So really, all you see is the outdoor compressor and then the heads themselves inside. Not very invasive at all when it comes to their installation in the home. Units are demonstrated to remain highly efficient down to about 13 below zero. When you really get below zero at that point, they can lose efficiency by maybe up to 10 to 15%, which causes them, when they're sized, to be oversized a little bit to meet that coldest day demand. And in the case study I'll go through in a little bit, I'll show you an example of oversizing one of these systems. But still, even when at the coldest temperature, and even here, when it gets down to that cold, at least yet, it's not really sustained too long. Maybe at dawn we're at our coldest temperature. But those low temperatures, again, tend to go up and that brings the efficiency of these outdoor compressors back up in the case of air source heat pump systems. This shows just how far the market for air source systems has come in even the last 5 years, but there are now cold climate hyperheat models to handle severe winters like we can experience here in upstate New York. The inverter-driven technology here allows heat capture in the worst winter conditions, even when there's a wind chill. And some of these units are able to defrost themselves by briefly reversing heat, and this is included in their efficiency rating. So if this is outside the home, you can see here, sometimes it will snow around the machine and it'll start to freeze up. They're able to reverse that polarity and warm those surfaces to keep the fan that extracts the heat running, even when it's super cold out. Now, if we were to experience a 5 or 6 foot snowstorm, you as a resident would absolutely want to go out and shovel some snow away from the unit itself. They don't have the ability to really melt themselves out of 5 feet of snow, but it's pretty neat that even over the last couple of years, they've been able to work this element of the technology in so that even when it's cold, these can still deliver 100% of home heating needs. These are some of the basic components. We have our compressors, always located outside of the home for air source heat pump systems. I didn't put images here of ductwork, we can all picture that. These are and I know we're a little bit of a color contrast issue here. These are the heads that are located on the walls in homes. Much like the remote I'm using here tonight, these systems come with remote controls to individually program the heads, as well as thermostats that can help us track energy use or electricity use in real time if you'd like to. And if we have any real techie type folks in the room, you could even explore the possibility of an upgraded thermostat from one of our installers where you're able to interact with an online dashboard and see very much like if anyone here drives a Toyota Prius, how your energy is being used in the home and in different zones of the home in real time. We'd like to point out that there are air source heat pumps for hot water heating. Domestic hot water can account for up to 22% of fossil fuel heating in New York State homes. These are standalone units like you see in the image here, often located in the basement or perhaps on the first floor of one's home. If you know that your hot water heater has had a good life and it's served you well, these really are a great bang for your buck, and especially if a whole home system isn't in your budget. These typically come in 50-gallon or 80-gallon sizes. You'll see those priced out on the price sheet, and I'll make a quick plug. If you didn't grab a price sheet on the way in, they're here on the table and also available on solartompkins.org. But these function independently. This is actually the heat pump compressor itself. It's located right on top of the hot water tank. And as I said, located either in the basement or on the first floor, just like the refrigerator, right, in our homes. They extract heat from the air of the room that they're in through the refrigeration cycle here in the heat pump, ramp that up to bring the temperature of the water up, and then service the home with hot water. These also provide a dehumidification effect for the areas that are immediately surrounding them, whatever room that they're in. May drop the temperature in that room by 2 to 3 degrees, but so do our refrigerators. Have we gotten used to that over time? We have. It's not something that we tend to experience, unless anyone here is particularly sensitive to that, which is possible. But just like a refrigerator, in the room or the area immediately surrounding it may drop that temperature there by a degree or 2.
How do these compare to on-demand?
Yeah, they take a little bit more time, but nothing significant to heat up and get up.
Energy, is that on-demand?
Yeah, as highly efficient. Going to move on now to ground source geothermal heat pump systems. You'll notice in this rendering here the piping in the ground. This is a loop field or a ground loop. We'll go through some of the common terminology here for geothermal systems. But we'll start here with how a geothermal system works. So the ground, even here in our climate zone, provides a relatively constant temperature for efficient year-round heat transfer. That temperature is about 50 to 55 degrees. Once you get below the frost line, which is about 4 feet down, temperature still throughout the year remains between 50 and 55 degrees. Ground source heat pumps can be installed in two ways. There are vertical systems, and that's the ground loop or the piping that you see in this example, and there are also horizontally trenched loop fields for geothermal. And I'll go on to share some images here that show them in real life application. In the piping that's installed underground here, water moves through the loop field and then couples with the home's HVAC system once it enters the home, typically through an incision in the foundation, where it meets the heat pump through that refrigeration and heat transfer cycle, like our refrigerators or window AC units. That temperature is ramped up and then sent through the home in existing ductwork. As I mentioned, inside of that ground loop piping is water. Through the HeatSmart program and in our best practices, we advocate water-based geothermal systems. There are others on the market, but from the research we've done, we feel these are the most efficient and the most environmental friendly. Inside of the ground loop piping is water mixed with safe food-grade glycol, typically at about 5 to 6%, to prevent freezing and facilitate heat transfer. We like to point out that on a case-by-case basis, ground source heat pump systems can connect with hydronic systems. So a lot of folks around here still have electric baseboard heating or radiant floor heating. And once the installer comes to your home and evaluates the age and the length of that distribution system that's currently in your home, there's a possibility that geothermal can be connected to that existing infrastructure based on a number of factors. And each of the installers that offer ground source geothermal in the program will be able to evaluate that on site for you. In this graphic here, we show again some of the basic components. Outdoor, we have our ground loop. In this example, again, is a vertical ground loop. These pipes, when drilled, and people sometimes refer to them as wells, have been corrected by some of the drillers in the room that they are boreholes. When these boreholes are drilled on your property, vertically, they're drilled at 300 to 500 feet deep. They can go right through bedrock. If they encounter an aquifer or groundwater, that's just fine. We know water is conductive. It actually helps the system in terms of its operation. And then the horizontal loop fields can be trenched, dug trenches, as shallow as 6 to 10 feet here in upstate New York. As long as you get below that frost line, which is typically at 4 feet subterranean, you can utilize that 50 degree constant, 50 to 55 degree constant ground temperature to operate your geothermal system. There's a price difference often associated with horizontal versus vertical systems, and we'll point that out a little bit later in the presentation. So outdoor, you have your ground loop system and your manifolded piping that comes into the home here through the foundation, where it meets the heat pump compressor. The heat is then ramped up, sent out through the blower fan and the blower coil to the ductwork to circulate air in the home. Down here you'll notice the excess hot water out, and then the term on the left, desuperheater. And this is essentially a hot water heater that services a ground source geothermal system. Excess energy that's created by the geothermal system can be used through a desuperheater to heat hot water. Just like the air source systems, they come with thermostats and remote controls, and they can be programmed to a variety of settings, and those thermostats also can be upgraded if one really wants to track and collect metrics on your home energy use through an online dashboard. Those are available, and you can speak with installers about those as adder costs later on in the program when I introduce those. Here are two graphics showing what happens outside and then what's happening inside of one's home with a geothermal system. Again, another graphic here of the loop field that comes into the home. Here in the basement, you see this unit. This tends to be about 5 to 6 feet tall, maybe a little bit more in the way that it's connected to the ductwork. But here in this graphic, you may see these dark colored pipes. These are wrapped in insulation. These are the pipes from the ground loop that come into the home that meet the heat pump itself, which is in the lower part of this unit. It's ramped up through these lines, goes out through the blower fan, and is sent out into the home through this ductwork. When this is switched for cooling, warm air is collected from the home through the intake, sent back here to the heat pump, and that warm air is sent out back into the ground loop in the earth, which cools the home on the inside. Okay, so real life pictures, geothermal systems. We'd be remiss if we didn't present that the installation of a geothermal system requires a significant amount of disturbance to your property, at least initially. So, for the average sizes of both vertical and horizontally installed geothermal systems, this is what we present in terms of figures. You'll notice in the graphic on the left, this is a drill rig. If someone is having a vertically drilled borehole installed on their property, a drill rig would come in, and for the average 4-ton system, the ground disturbance is roughly about 20 feet by 20 feet. In the case of an horizontal installation, it's tough to really tell the scale from this image that I grabbed offline, but for the same size system that is trenched horizontally, obviously it's much larger. This is roughly 33 feet by 250 feet. As I said, it's much shallower than the 300 to 500 foot vertical borehole. These are on average around here 6 to about 9 or 10 feet, depending upon the slope of one's property, the soil type, and some other factors, the removal of large rocks, etc. You'll notice on the pricing sheet, as I mentioned, there are often price differences associated with horizontal versus vertical, and obviously that depends upon your property type, property location, and then again, soil type and the existence of large rocks, and your installers can educate you, if you will, on what type would be best suited for your property. Yes, sir?
It doesn't look like 4 feet.
I know, yeah. The context of this image, it was tough to really get one that you could really see was, oh, well, that loop field is trenched about 8 feet deep. If we were to really get down here and you looked at the piles of dirt here on the side of it, it can't be any shallower than 6 feet deep here in Tompkins County or the surrounding area. So it's tough to really tell with the context of this image, but they are trenched at a minimum of 6 feet, and between 6 and 10 feet, depending upon your individual property.
So this was in Georgia?
No, this one is in New York State. It's a poor image.
Okay.
You know, whether it's the resolution or the angle, it's just tough to really see that this is, you know, actually a minimum of 6 feet deep. So with that introduction to the technologies, how do we move forward with adopting a home energy efficiency package through the HeatSmart program? I mentioned earlier that the HeatSmart program is predicated on the successful Solarize model. Again, it's a U.S. Department of Energy program delivery that we've expanded past the solar programs that Solar Tompkins has done and molded around the offerings of insulation, air sealing, and the heat pump technologies. So this was our process for creating HeatSmart. We designed an RFP, a request for proposals, that was sent out to the industry around Tompkins County and said, we're looking to do a program that offers these types of products and services. Why don't you submit qualifications to us, and we'd like to have you participate. We went through a very rigorous interview process, as well as reference checking and system installation checking around the county to select the 3 installers that we have in the room with us tonight. Halco, your back right, Zerodraft, your back left, and then to your hard left over here is NP Environmental and Upstate Spray Foam. In trying to promote small business through the HeatSmart program, we gave small businesses the opportunity to form a consortium or form a team to go out and get an equally qualified partner to deliver services. And so we've had them take us up on that. We've been doing our marketing campaign since mid-September. You're here tonight at the last public meeting, and we thank you for coming out. And for the rest of tonight's presentation, I'm really going to talk about enrollment through the decision to contract and go through installation. I just mentioned that we have our installers in the room. They each offer something different when it comes to the program, and we'll go around and have them do individual introductions at the end, and they'll tell you a little bit about their business, where they're from, and the services that they bring to the program. So you'll hear from them directly in just about 15 minutes or so. And once you enroll, this is what you can expect through HeatSmart. Enrollment is a no-obligation process. Essentially, you do a little due diligence and you choose one of these 3 installers to work with. It's not a binding decision, but once you choose to enroll, you receive what we call a site assessment or a preliminary envelope assessment. It's a home energy assessment for your home. Many folks have had this done through a variety of services or companies locally. And you have that done again via one of our installer partners when you enroll. And this home assessment will inform you of your home's insulation needs and options, help size a heat pump system for your home, and then provide you a set of proposals for you to consider to go forward in contracting. What's nice about HeatSmart is that it's very flexible. You can, with one of the proposals returned to you, just consider the insulation and air sealing element of that proposal. As I mentioned earlier, you may just consider the air source heat pump element of that proposal. It's up to you as residents to choose what best fits your budget and your home's existing state. It's possible that you just had an installation job done 5 or 6 years ago and your home is very tight, and that will be shown through your energy analysis. You don't need any upgrades there. So it's up to you to choose what element of those proposals are best for your home. These are the elements of the site assessment. The inspection includes the measurement of dimensions of the home, the current state of insulation and ductwork, and then engages in infrared imaging, this image here at the top right, as well as a common blower door test to inventory air leaks and circulation in the home to then create the heat load calculation for your specific home. As I mentioned earlier, no home functions the same in terms of its energy use or consumption. So the heat load calculation is very important to determine accurately so that a system size is determined appropriately for your home. One way to get an even more accurate heat load calculation is to allow your installer to pull utility data for your address for the prior year. Seeing how the home is currently using energy and what the source was gets factored into the process for determining that heat load calculation number. Again, that number is given in the size of tons. So a lot of this work is done sort of behind the scenes. The installer comes to your property, spends some time doing the home energy assessment, then takes all that data back, puts it through a nationally certified software program that we require through our best practices. It's a manual J calculation, and ultimately that determines the heat load calculation to size a home heating and cooling system with an insulation package for your home. Installer partners present at least 2 options for a mix of insulation, air sealing, and a heating and cooling system. All proposals are based on the pricing guide, the better than market pricing that we've negotiated with these installers to have them join the program in the first place. And these proposals will include a description of all available state and federal incentives and tax credits that are available to you. How are we able to arrive at below market rate pricing? As I said, it's about 20% below market rate. These pricing categories, the categories of insulation and air sealing products and services, the air source heat pump products and services, and the ground source geothermal products and services have been standardized. If you look at the pricing guide, you'll see that neither of the installers have the exact pricing. It's not fixed pricing across the board where they each offer the same products and services at the same increment. As long as they've come down 20%, they offer different brands and different services, and that's their prerogative. So keep that in mind as you peruse the pricing sheet. But this is publicly available. You can contact myself at HeatSmart and absolutely dialogue with your installers about the prices for their different brands and their different services. What we've been able to do is reduce soft costs. These installers don't have to find you on the open market by cold calling or printing marketing materials. We put everyone in the same room. We've done our background checks and our vetting process, and these are the quality companies that we feel would best serve county residents, and we put ourselves all in the same room here to get to know one another and hopefully move forward. You'll also notice on the pricing guide some adder costs. It's possible that with the removal of vermiculite contaminated insulation, like I mentioned earlier, or after the installation of a geothermal system, one thing I didn't mention on that slide is that we all know how seriously we take our properties. We play on them, we garden on them. They're a representation of us in terms of the way we design or plant them, and that ground disturbance is a big deal for a lot of people. A lot of people say, I really don't want my property ripped up. It is the responsibility of our installers to return that property to the state that it was prior to installation. So when it comes to construction grade leveling, reseeding and strawing, the removal of large rocks, that's all accounted for under the HeatSmart pricing. But let's say you wanted to go beyond that. Oh, I always wanted some shrubbery or a hedgerow there. You can consider that as part of an adder cost with one of these, with one of our installers. Again, I mentioned upgraded thermostats or the greenhouse gas-free blower agents and spray foams. You'll see those priced out on the HeatSmart pricing guide, and those are categories to speak with your installer about if they interest you above and beyond some of the basic services through the program. As I mentioned, we ask that you initially pick one installer partner to work with. We feel that because we've brought down prices below market rate, that there's no real need to bid out each of the partners. And we experienced through the solar program that about 95% of program participants picked and decided to stick with one installer through the whole process. It doesn't mean that if you start down the path of a geothermal system and decide, you know, I really want air source, I think that's better for me or it's better for my budget, all you have to do is contact HeatSmart. Essentially, it's sending me an email or making a phone call, and I redirect your lead to one of the other installers. You know, we realize that this is asking a large commitment financially, and just maybe legacy-wise. If one wants to update their home and say, you know, I really want to live in an energy-efficient home, I'm not sure how long I'm going to be in this property, but it's so important to me to make one of these property upgrades. You know, we take that as seriously as you do. And it's about doing the necessary due diligence on your end first to then decide to choose one installer and go with them. On to incentives. And we realize that this is a very important part of the HeatSmart program and for considering having home energy efficiency work done. So what's available at the state level? Through NYSERDA, which is the New York State Energy and Research Development Authority, they have a number of programs, 3 here listed on the slide, that service the insulation and air sealing portion of the HeatSmart program. Those families above 80% of county median income are eligible for a 10% grant up to $3,000 and a low-interest NYSERDA loan. That's the NYSERDA Home Performance Program. Tompkins County families below 80% of county median income are eligible for a 50% grant up to $5,000 and a low-interest NYSERDA loan. That is the Assisted Home Performance Program. And then families below 60% of state median income are eligible for 100% grant of selected measures for insulation and air sealing. Each of the installers are well versed in these programs, and again, when it comes time for us to get up and circulate and dialogue with them, do ask them about the median income levels for various size households and how those may apply to a job that you're considering. At the federal level, all ENERGY STAR certified geothermal heat pump systems are eligible for a 30% federal tax credit. Through our best practices, we don't offer, or I should say, we have our installers offer only ENERGY STAR certified projects or products. So anyone choosing geothermal systems will qualify for this 30% federal tax credit. What's also nice about pursuing the tax credits or state incentives is that the installers complete the paperwork for you. Often that can be an arduous process, and they take it upon themselves to really guide you through and go ahead and fill out that paperwork and submit it for you. Unfortunately, at this point in time, there are no state or federal incentives for air source heat pumps. Something that we really hope will be considered at the state level, but at this point in time, something that is not available to us as residents. What are some of the financing options available locally? It's been fun for us to go around and develop relationships with our local institutions, whether it's Alternatives Federal Credit Union, M&T Bank or Tompkins Trust Company. We've sat down with them, and each of them have products available. We know that Tompkins County residents like to bank locally, so if you're interested in financing with whoever your local bank may be, if it's one of the three I just mentioned, be sure to drop in and speak with a representative there. In addition, NYSERDA on the side of unsecured loans offers a 3.49% for 5 to 15 years, up to $25,000. There's also home improvement loans available at 6 to 7% for 10 years, up to $30,000. With regard to secured loans, home equity loans or lines at 3.5 to 4.5% for 20 years, up to 85% of home valuation minus mortgage. And other products are available through the installer partners, as they also have relationships with regional and national banks that we encourage you to speak to them about. At this point in the presentation, I'd like to go through 2 case studies. I realize that this has been a lot of information already, but to really put this in real-world context, go through one example of the installation of a ground source geothermal system, and then the second case study highlights a ductless air source heat pump example. So we'll consider this my home. It's an average 2,000 square foot home with a heat load of 4 tons. The reason that we chose 2,000 square feet is just easy to normalize some of these numbers. The average size of a new home built today by the home builders is about 2,000 to 2,200 square feet. It's quite a considerable amount of space, as we know, but we chose that metric. And to have a home heat load of 4 tons is one of the average calculations for a residential home here in Tompkins County. I'm currently heating my home with propane. It's costing me just over $3,300 per year, and I'm searching for alternatives. I had an installer come to the home. They did the preliminary site assessment. They collected the data on how my home is performing energy-wise. They took that back, then came to me with a proposal. In this proposal, for insulation and air sealing, they suggested cellulose on the attic flat, spray foam down in the basement to improve the moisture and thermal heat loss barrier, and after these improvements, a 3-ton horizontal ground source geothermal system to meet my new home heat load. You'll notice that we're at a 4-ton heat load for the home, but then a 3-ton geothermal system. That's because the insulation package, through its installation, brings our heat load size down by a full ton, and that's how then the geothermal system is sized. And so the total costs here, I'll point out on the bottom here, the unit costs are all on the pricing sheet that you have in front of you, so we went ahead and just put total costs up here for the sake of the full-blown math exercise. About $3,500 for 14 inches of cellulose in the attic, just over $1,000 for 3 inches of insulation, spray foam insulation around the rim joist, and then just shy of $2,000 for 3 inches of closed cell spray foam on the basement walls. After this, we have the 3-ton horizontal ground source geothermal heat pump system priced at $19,500. This brings the project sticker price to just over $26,000 before incentives. Once we apply those, that's the 30% federal tax credit for the Energy Star certified geothermal system and the 10% NYSERDA incentive for insulation and air sealing. That brings the final project cost down to $19,500. We then applied a pretty standard 3.49% 10-year financing package on this project. Bless you. And that brought us out to $262 per month for the finance cost plus the operating cost of the insulation and the ground source heat pump system in year 1. Currently, I'm paying $276 for propane. So right off the bat, that's an initial savings of $14 a month with no upfront cost. If you keep in mind that at the end of that 10-year loan, your price goes down to just running that geothermal system on electricity. $68 a month here in this example. These are forecast on today's price for electricity, which are also forecast to stay relatively flat compared to propane and fuel oil as we go into the future. Natural gas, as we know, still remains competitive, very competitive at pricing today, although it is projected to still rise, and pretty sharply, over time. So, in constant dollars then, your savings over 15 years in case study 1 for the insulation package and the ground source geothermal system, the horizontal geothermal system, savings $14,300 over 15 years. We also decided to quantify greenhouse gas emission savings, as Solar Tompkins is dedicated to the environmental benefit of this type of heating and cooling system as well. So with reduced propane use, despite an uptick in your home's electricity load, it's still a net 74% savings per year of greenhouse gas emissions. If you are currently on solar or considering solar, or if you work with an ESCO, that's an energy service company that supplies your address with 100% renewable energy, this is about as close as you can come to operating a carbon neutral home. I'm going to move on to case study 2 now. It's the same home, 2,000 square feet. It's been determined by my installer partner to have a 4-ton heat load. I'm using propane still. It's costing me $3,300 a year, and I'm really searching for alternatives. The preliminary site assessment returned a proposal for the exact same insulation package, but this time an air source heat pump system, a 3.75-ton ductless air source heat pump system for the home. At this point in the presentation, people have often asked me, so why do you size the air source heat pump larger than the ground source geothermal system? And I mentioned this a little bit earlier in the presentation. And the reason is, geothermal systems, the components for them are typically located in the basement. They're protected from the elements, right? The compressors for air source heat pumps are located outside typically because they are exposed to the elements. Their efficiency, when the temperature drops very low, can decline. Not to the point of being inefficient, you know, with the advance in the market, they operate at super high efficiencies. That's how they're able to function still at 200% efficiency with seasonally averaged operation, but they still need to be oversized to some degree to meet coldest day demand. Therefore, we size them up just a little bit, we as in our installer partners. And HeatSmart Tompkins takes that into account so that air source heat pump systems can still meet 100% of home heating needs through the winter. The geothermal systems rely on ground temperature, which is constant, so they don't have to be oversized at all, and air source heat pumps differ in that one way. Their compressors are located outside, while the compressors for geothermal systems are protected indoors. So the total cost for this proposal, it's the same insulation package at just shy of $6,000. The sticker price for the ductless air source heat pump system in the home, sized at 3.75 tons, has a final project cost after the 10% NYSERDA incentive of just about $16,000. As I mentioned a few moments ago, unfortunately right now there are no tax credits or incentives for air source heat pumps. Applying the same financing package of 3.49% over 10 years, it's $251 per month to pay the finance cost, essentially the operating cost together, of the installation and the electric-based ductless air source heat pump, compared to $276 a month for propane. It's a net savings upfront of $25 a month. Again, at the end of the 10-year loan, the cost goes down to supply the air source heat pump system with electricity, which is what operates it. In the last case study, that figure was 68. Because this system has been sized up a bit, that electricity cost is a bit higher. Total savings of this home energy system over 15 years over my propane system is about $15,200. Again, even though the grid is still powered mainly by fossil fuels, by offsetting propane use, even if you are increasing your electricity load to the home, in this example, per year, you're saving 64% greenhouse gas emissions. And again, if you're utilizing solar, you're operating pretty close to carbon neutral at your home You can also choose to work with an ESCO, an energy service company, to supply your address with 100% renewable energy. That also brings your greenhouse gas emissions down. Yes?
Why don't they put the air source compressors in the basement?
Question was, why do we not locate the compressors for air source heat pump systems in the basement? They need constantly moving air to draw the greatest amount of heat from. So if they were in the basement, the air would be warming up around it and it would be drawing in warm air all the time. It really needs to have a constant flow of air past it. So also in our siting guidelines and the best practices, the installers, when they site these, I mentioned 20 inches off the ground or bracketed to the side of the home. You can put, say, a cover over it so it doesn't get snowed on, but you usually wouldn't want to have them boxed in because it really depends on constant airflow past those compressors.
What's the average life expectancy of those?
The compressors for the air source heat pumps are right about 15 years.
So it'd be $10,000 again after 15 years
To replace it?
to replace it?
No.
Let's go to one of these.
No, it wouldn't be $10,000 a year to replace it. And even conventional systems, you see central cooling systems, they've lasted up to 20, 25, even 30 years. It really depends on the conditions exposed to outdoors. But the compression cycle, the vapor compression cycle within the unit itself, it's a closed loop system. So there's really no outside effect on it other than the weather that affects the fan and the coil within the unit. So at that point, to answer your question, if a compressor or component were to go bad, it could be as simple as maybe $100, $200. So it's not to say that you'd have to replace the whole unit. Plus your interior units, it's just a fan and a coil inside too.
How long are they guaranteed?
10 years.
10 years.
10 years.
So if I heard of one that failed at 3 years,
Okay.
that would have been.
That'd be covered under warranty.
And how soon would somebody be out to replace it?
To replace it?
Yeah, if you were dependent.
Well, if you were to give a call and you had an issue with the system, we'd send somebody out immediately. And to get a replacement.
Yeah, but does that person have it in their truck or?
No, it's not a unit that we would have in our truck, but typically it's something that the supplier stocks that we could get the same day.
So, warranted for 10, average life expectancy on the outdoor compressors for air source heat pumps at 15 years. For ground source geothermal systems, the piping in the ground is slated at about 50 years, and the compressors, because they're not exposed to the elements and they're typically inside, are 20 to 25 years. I'm going to end here on the pros and cons, some pros and cons of both type of heating and cooling system. So with regard to air source heat pumps, minimal infrastructure really is one of the pros. There's no extra heating distribution cost, a very small footprint for equipment. It's just that 2x3 compressor located outside the home, and then either you're using existing ductwork or you're dedicating some wall space to several mini split units that are mounted on the wall. No property digging required, as there is for geothermal systems. And there are a few adder costs overall that affect final price. With regard to cons, as we mentioned, outdoor compressors are exposed to the elements. Therefore, the maximum British thermal unit BTU output declines at very low temperatures, those below zero, and typically about 15 below zero. And their COP, which is an acronym for coefficient of performance, their efficiency, essentially, is slightly lower than for ground source heat pump systems as a result. With regard to ground source geothermal systems, on the pro side, they absolutely have the highest efficiency for seasonally averaged operation at 300 or more %. They utilize existing heat distribution ductwork in homes. They are subject to the 30% federal tax credit to reduce final project cost. There's no oversizing of these systems to meet cold day demand. Ground loops last on average 50 years or so, and the pumps and compressors are protected indoors. Cons, they require more land area in terms of installation. Adder costs can arise when there's vertical drilling of the loop field versus horizontal trenching. And then there's the issue of property remediation if one wants to add additional cost to the property in terms of its maintenance. With regard to heating distribution upgrades, the adaptation to hydronic systems that I mentioned earlier, as said, that can be on a case-by-case basis. If someone is set on using existing hydronics, it may be necessary to extend those hydronics to meet a different temperature need to match the old age of that infrastructure with the new infrastructure of a geothermal system. And we'll ask the installers to answer some of those questions in just a moment. And prices can rise sharply for geothermal systems if someone isn't eligible, someone say on a retirement income, doesn't make enough to qualify for the 30% federal tax credit. So how do we move forward with HeatSmart at this point in time?
Back up. You had mentioned that the vertical system costs more.
Yes.
And that, you may not be able to answer this, maybe the installers can, because I'm sure there's lots of variables. But how much more is a vertical system as opposed to a horizontal system?
On the price sheet, we have an example at 15%? 50%? 50%? But then again, each system is sized differently, so that number is subject to gain or fall. So, how do you move forward then with HeatSmart? We realize that this is a whole lot of information to take in during a 1-hour presentation. So we appreciate your attention, we appreciate you coming out. We hope that you will stay and ask me some questions and dialogue with our installers who can bring the technical prowess to answer some of your questions. Review our pricing guide that's offered through the program. Consider access to state and federal incentives as well as financing options. We really try to have solartompkins.org be your one-stop shop for all this information. In addition, I said this is our last public event. This is our last full-scale public presentation, but this Saturday at the Ithaca Coffee Company at Trip Hammer Mall from 10 a.m. to 12 noon. I'm going to have a Q&A session. It's a real informal, come in for a free cup of coffee, ask HeatSmart staff and one of our installer representatives some more in-depth questions, maybe about your property, or anything that percolates in your mind after tonight's presentation. But we'll be there for several hours again at the Ithaca Coffee Company this Saturday. That's the location up at the Trip Hammer Mall, not the one downtown. So feel free to come out and join us there. We have done community tours in the past where we had a number of addresses through September, October, and November where we were inviting residents to not just hear it from us, but come and visit one's property that either had a ground source geothermal system or a air source system installed. And if you'd like to consider talking to another resident about their experience, feel free to send me an email or give me a call. My contact information is on solartompkins.org, and I'd be happy to check if one of those county residents would be willing to speak with you either in person or by email, etc. It's a nice way to hear about other people's experiences when it comes to installation, operation, cost savings, etc. So please consider that. And enrollment would be something to consider at this point in time, and I can answer any questions about that when we wrap up here. But first and foremost, we thank you so much for spending this time with us this evening, and we look forward to having you be a part of HeatSmart should you choose to go forward. Thank you.
Any questions?